Alright guys, we're going to go ahead and start with the calendar math. So if you look at the piece today, today is the 7th, and it is blue. And so if I draw my piece, we have what kind of shape? I'm going to let you guys work that out. Talk about it. Is it a triangle? Is it a quadrilateral? A pentagon? A hexagon? A parallelogram? A square? A rectangle? A rhombus? A trapezoid? Or a regular shape? And remember, it can be more than one thing. Today's amount, after going through the weekend, we are left with 18,000. We're going to subtract 7,000 to get your new total. There are 5/12ths today, and if you look at the back of the room, go ahead and you can imagine the 12th being colored in, and I will color that in tomorrow. Are there any equivalent fractions today? Alright, our daily decimal, we are on the 62nd day of school. So how do we write that as a decimal? And how do we write that as a fraction? Are there any equivalent tenths? Is 62 over 100, is that 62 a multiple of 10? Okay, for the power math today, you have 1/4 plus 2/3. Remember, you need to find a common denominator. In this case, we can just multiply 4 times 3 using the bit of a shortcut that I showed you guys Friday. 4 times 3 is 12. And then you can cross multiply to find the numerator. So 4 times 2 is 8. 3 times 1 is 3. And 8 plus 3 is 11 twelfths. There is not a number that can go into both 11 and 12 evenly, so that is our answer. When you look at number 2, we have 1 1/5 minus 3/4. All right, we're going to put that 1 out to the side and find our common denominator. In this case, it's 5 times 4, so 5 times 4 is 20. 5 times 3 is 15. 4 times 1 is 4. Since I cannot take 15 from 4, we need to change our whole number to a whole number fraction using the common denominator of 20. So our whole number fraction is going to be 20 over 20. We're going to add in the 4/20ths that we already have, and then subtract the 15/20ths. So 20/20ths plus 4/20ths is 24/20ths minus 15/20ths. And what is that answer? Okay, so that answer is 9/20ths. Again, there is not a number that can go into both 9 and 20 evenly, so that is our answer. Number 3, you have 9 67/100 times 1 5/10. Remember, you do not have to line up your decimals when you are multiplying. You just need to line up this last column of numbers. So 7 times 5 is 35. Put down your 5, carry your 3. 5 times 6 is 30, plus 3 is 33. 9 times 5 is 45, plus 3 is 48. Then you move on to the 1. 1 times 7 is 7. 1 times 6 is 6. 1 times 9 is 9. You add it up, you put a 0 there. 5 plus 0 is 5. 7 plus 3 is 10. 8 plus 6 is 14, plus 1 is 15. 9 plus 1 is 10, plus 4 is 14. Now we come in, where is our decimal hiding? It's hiding behind the last digit, and we count the digits behind our decimals in the problem. So we have 1, 2, 3 digits behind the decimals. We're going to move our decimal 3 places. 1, 2, 3. So our answer is 14 and 505 thousandths. Moving on to number 4, you have 1 and 23 hundredths divided by 3. First thing you do is move up that decimal. Can 3 go into 1? Is 3 smaller than 1? No. So 0 times 3 is 0. 1 minus 0 is 1. Bring down your 2. Is 3 smaller than 12? Yes. So 3 times what will get you close to 12 or 12 exactly? 4. 4 times 3 is 12. Subtract. Bring down your 3. 3 can go into 3 one time. 1 times 3 is 3. And you have 0. Moving on to number 5, you have 21 and 6 tenths divided by 9. Again, bring up that decimal. 9 cannot go into 2, so we can subtract and go ahead and bring down the 1. 9 can go into 21 2 times. That's 18. 21 minus 18 is 3. Then bring down our 6. And 9 can go into 36 4 times. 9 times 4 is 36. Alright, for 6a, I wanted you to simplify this fraction. So what number can go into both 4 and 12 evenly? 4 can go into 4, and 4 can go into 12. So 4 divided by 4 is 1. 12 divided by 4 is 3. 6b, you have 21 over 24. So you have to think about your multiples, your multiplication facts. What number times another number will equal 21 and 24? And remember, it has to be the same number. Well, I know that 21 can be made with 1 and 21. So if I can write this out, you have 1 times 21 makes 21. And you also have 7 times 3 makes 21. Well, are there any of these numbers, the 1, the 21, the 7, or the 3, that can multiply times something else to get you 24? Well, for 24, you have 1 times 24. You have 2 times 12. You have 3 times 8. You have 4 times 6. So which of these has the same factor as the other? Well, you have your 1s, but that's not going to change anything. And then you have the 3s. So that means that 21 can be divided by 3, and 24 can be divided by 3. And 21 divided by 3 is 7, and 24 divided by 3 is 8. So there's your simplified fraction. Alright, moving on to 7a. I wanted you to change that to mixed numbers, so you're starting out with 16 over 5, or 16 divided by 5. So when you actually work that out as a division problem, 16 divided by 5. 5 can go into 16 3 times. 3 times 5 is 15. 16 minus 15 is 1. Your quotient is your whole number. Your remainder is your numerator. And your denominator will stay the same. So your answer is 3 1/5. Looking at 7b, you have 13 over 4, or again, 13 divided by 4. So doing the problem, 13 divided by 4. 4 can go into 13 3 times. 3 times 4 is 12. 13 minus 12 is 1. Again, your quotient is your whole number. Your remainder is your numerator. And your denominator stays the same. So your answer is 3 and 1. Number 8, we're back to just simple adding of fractions. 2/5 plus 5/6. Our denominator is going to be 30. That's 5 times 6. When we multiply our denominators to get our new denominators, that's when we can do our cross multiplying. So 5 times 5 is 25, and 6 times 2 is 12. 12 plus 25 is 37 over 30. We're left with an improper fraction. 30 can go into 37 one time, and that's 30, and 37 minus 30 is 7. So our mixed number is 1 and 7/30. Number 9, we have 1/2 plus 4/7. Again, we can multiply our old denominators to come up with our new denominator. So 2 times 7 is 14. 2 times 4 is 8. 7 times 1 is 7. 7 plus 8 is 15. Denominator is 14. 14 can go into 15 one time. We have 1 as a remainder. Can you see the division problem? One time, that's 14 and 1. So 1 and 1/14. And the last problem for your power math, you have 5/8 minus 1/4. All right, this is one of the cases that I wanted to show you. We could have a common denominator of 32. Just to show you how that would work, again, 8 times 4 is 32. 8 times 1 is 8. 4 times 5 is 20. And 20 minus 8 is 12 over 32. And then you can simplify by, 4. And so 12 divided by 4 is 3, and 32 divided by 4 is 8. But another way that you can also do that is you can look at your two denominators. Let me erase this word. Remember, we got 3/8 as our answer. So we can look at these two denominators, and is there any way that one of these denominators can become the other by multiplying? Well, you can look at your 4. And change. All right, so 4 times what will get you 8? 4 times 2 will get you 8. So you can multiply 4 times 2, and whatever you do to the denominator, you need to do to the numerator. So this 5/8 can stay the same, and your 1/4 now becomes 2/8. And now when you subtract 5/8 minus 2/8, you get the same answer that we got before, 3/8, but now you did not have to simplify. All right, you can pause the video and pass out Lesson 7 problem set. Guys, we're going to do Lesson 7 problem set together, one problem at a time. And then when I am done with the instructional video, you will go ahead and complete Lesson 7 homework set as independent practice if you still have time left in math class. You may work with your partners as usual, but if it gets too loud, your substitute can shut it down and you can work on it all by yourself. It's your choice. All right, you guys should have your Lesson 7 problem set in front of you. We're going to do one problem at a time. Whatever I do on the board, I want you guys to make sure you do it on your paper. I will tell your substitute to pause the video at certain points so that you can have time to work out the problems. But again, I'm going to be working out every single thing with you guys. So let's go ahead and get started on number 1. I want you to read the problem as I read it. George weeded 1/5 of the garden, and Summer weeded some too. When they were finished, 2/3 of the garden still needed to be weeded. What fraction of the garden did Summer weed? You can underline this important information. George weeded 1/5 of the garden. I want you to circle the word some, so you can underline Summer weeded some too, but I want you to circle some. Then you can underline 2/3 of the garden still needed to be weeded. And of course the question, what fraction of the garden did Summer weed? So what we have here is we have a garden. We don't know how much the garden is or how big it is or anything like that. We just know that we have a whole garden. And we know that George weeded 1/5 of the garden. So that's George. We know that Summer weeded some, but we don't know how much. So this is Summer. And then we know that 2/3 of the garden still needs to be weeded. It's what is left. I guess we can put left to weed. So we have a whole amount. So we can write this. If we're going to be doing our labeling, we have one whole garden. And then to find out what Summer weeded, you have to take away what you know was done to the garden. So we have one whole garden minus the 1/5 that George weeded. So 1/5 for George minus the 2/3 of the garden that is left to weed. Alright, well, how can I take away one whole, or rather, how can I take away 1/5 from one whole? What needs to be done in order for you to subtract fractions? You have to have that common denominator. So, writing it out just with numbers, you have 1 minus 1/5. Well, guys, when you have a problem like this, when you have a whole number, and that is, or a fraction that's being subtracted from a whole number, you can just go ahead and look at that denominator that is already there. So 1 whole can be written as 5/5 minus 4/5. Oops, I'm sorry. I just gave y'all the answer, didn't I? Let's see. 5/5 minus 1/5 is equal to 4/5. So after George weeded the garden, 4/5 of the garden was left. Alright, now Summer weeded some, but we still don't know what that is. So after Summer weeded, there were 2/3 of the garden left, so we're going to subtract 2/3 from the 4/5. In this case, again, you are going to have to find a common denominator for 5 and 3. And looking at those two numbers, you can tell that there's not going to be another common denominator for 5 and 3 than 15. So 5 times 3 will give you 15. 5 times 2 is 10. 3 times 4 is 12. And so now when you subtract, you have 12/15 minus 10/15 equals 2/15, and that's going to be the amount that Summer weeded. Okay, and if you go back in and label it, so this one whole is the whole garden. The 1/5 was what George did. We'll just abbreviate with a G. Alright, the 2/3 here is what was left to be weeded. And recognize that this 2/3 then became equivalent to 10/15. So this 10/15 is still what is left to leave. So then when you subtract the 12/15 that was left after George weeded minus the 10/15 which was left to leave equals 2/15 that Summer weeded. Alright, let's go ahead and move on to number 2. Number 2, Jean spent 1/3 of her money on a pack of pens, 1/2 of her money on a pack of markers, and 1/8 of her money on a pack of pencils. What fraction of her money is left? Alright, so again, she has some money. We don't know how much money she has exactly. So we draw a bar and we label it money. Alright, she uses 1/3 of her money, so we're just going to kind of partition this box up just to give us a visual of what we're looking at. 1/3 of her money on pens. She uses 1/2 of her money on markers. She uses 1/8 of her money on pencils, something that you guys don't spend your money on, and we have an amount that is left. We're going to work this problem the same way that we worked the other problem. We have one whole amount minus the 1/3 that she spent on pens minus the 1/2 that she spent on markers minus the 1/8 that she spent on pencils. And that's going to equal the money that is left. Now, when you're subtracting, you don't need to try to subtract everything all at once. You subtract two amounts each time. So we're going to start with our one whole amount. Our one whole minus the 1/3. 1 minus 1/3. Again, you have to have that common denominator, and since we already have a denominator of 3, we can change this one whole to 3/3 minus 1/3 gives us 2/3. Alright, this 1 minus 1/3 was the pens, so we did that. Alright, now we need to take this 2/3, which is what she has left after she spent the 1/3 on the pens, and we subtract the 1/2 for the markers, minus 1/2, and we'll label that markers. Right now, I can't just subtract. I have to find a common denominator for 3 and 2. So our common denominator for 3 and 2 is going to be 6. 3 times 2 is 6. 3 times 1 is 3. 2 times 2 is 4. So this 1/2 actually became 3/6. So we have the 4/6 that's left after she bought the pens, minus the 3/6, which is the markers, and she has 1/6 of her money left. So now we've done the markers. We have 1/6 of her money left, and now we need to take away the 1/8 for the pencils, minus 1/8 for the pencils. Alright guys, I'm glad this problem came up because I wanted to show you another way that you can find the common denominator. You already know that you can multiply 6 times 8 to get to 48, but then you're going to have to simplify. You've also seen a problem where sometimes the denominator can become the other denominator by multiplying. In this case, a 6 can never become an 8 by multiplying. So Now I want you to kind of look at it as what other number, what multiple can both 6 and 8 get to? So if you have a 6 and you have an 8, then you can list your multiples to see what they get to, a common multiple. Well, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. Since I'm kind of running out of room, I'll stop here. Well, let's look at 8. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32. Do we see a number that is the same for both of them? Okay, 24. So 24 and 24 are both multiples, or it is a multiple for both numbers, which means that it can also be a common denominator. Well, what can I do to 6 to get to 24? We multiply it by 4. Whatever you do to the denominator, you do to the numerator. So 1 times 4 is 4. What did I do to the 8 to get to 24? Multiplied by 3. Again, whatever you do to the denominator, you do to the numerator. So 1 times 3 is 3. Now we have 4 24ths, and the 3 24ths, that's equivalent to the 1 8, gives us 1 24th left. You did not have to simplify to get to that 1 24th because you found another type of common denominator, a lowest common multiple. All right, you can pause this video now to discuss any kind of questions that you might have. All right, picking back up. Number 3, Shelby bought a 2-ounce tube of blue paint. She used 2/3 ounce to paint the water, 3/5 ounce to paint the sky, and some to paint a flag. After that, she has 2/15 ounce left. How much paint did Shelby use to paint her flag? All right, so again, you have an amount. In this case, she has 2 ounces, 2 whole ounces of paint. She uses 2/3 of it to paint water. She uses 3/5 of it to paint the sky. She uses some to paint a flag. And she has 2/15 left. All right, in this case, instead of 1 hole, how many holes do we have? We have 2 holes. So we have 2 holes minus the 2/3 for the water, minus the 3/5 for the sky, minus the 2/15 that is left will give us how much is left or what she used for the flag. We can still solve this problem the same way that we solved for the 1 holes, except now that we have 2. So if I have 2 minus 2/3, again, I have to use the denominator that is shown here in the fraction, and so we have something over 3 minus 2/3. Well, we don't want to use 3 over 3 because 3 over 3 is 1 whole. So what can my denominator be, or I'm sorry, what can my numerator be to equal 2 wholes? And remember that a fraction simply is another way of saying divide. So what numerator can I have that can be divided by 3 to equal 2? What divided by 3 equals 2? All right, well, if I look at it, I just erased it too much. So 2, and then we have something divided by 3. 6 divided by 3 equals 2, so that is equivalent. And we didn't have to change our 2/3, so now 6/3 minus 2/3 is 4/3. This is the water. Alright, so after she used the amount for the water, she has 4/3 left. Now she uses 3/5 of that to paint the sky. As if we go back, and I kind of want you to get into the habit of doing this, to find that lowest common multiple, if you look at 3 and 5, and this is just to prove that the lowest common multiple is going to be 15, but just to kind of look at it this way, you have 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. And then you do 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. So our lowest common multiple is going to be 15. You're looking at it like 15 and 15, and 3 times 3 is 9, 5 times 4 is 20, 20 minus 9 is 11, 15. So this 3/5 is the sky, and that 3/5 became 9/15. So this is also the sky, and so now we have 11/15 left after she used the amount for the sky. She painted some for the flag. We don't know what that is. We're about to get to it. And after she painted the flag, she has 2/15 left. Well, thank goodness we've already got a common denominator here. So 11/15 minus the 2/15 that was left is 9/15. So she used 9/15 to paint her flag. Right now you can simplify 9/15. You can divide both the 9 by 3 and the 15 by 3 to get 3/5. That's the simplified answer. Alright, we just have 2 more problems left to do. So let's look at number 4. Number 4. Jim sold 3/4 gallon of lemonade. Dwight sold some lemonade too. Together they sold 1 5/12 gallons. Who sold more lemonade? Jim or Dwight? How much more? Alright, so we have an amount, and they've given us the total lemonade that they sold all together. It says together they sold 1 5/12 gallons. And we know that Jim sold 3/4 of the gallons. That's Jim. But we don't know how much Dwight sold. So now we have a specific, so we don't just have, a whole or anything like that. We have a mixed number. We have 1 5/12 total amount minus the amount that Jim sold, which is 3/4, equals what Dwight sold. And this is Jim. Alright, so doing our subtraction just like we have done, we've done a mixed number before, so we have 1 5/12 minus 3/4. Guys, take a look at those denominators. Is there a denominator here that can become the other denominator? We have 12 and 4. Well, 12 can't become 4, so 4 can become 12, and it can be done by multiplying by 3. 4 times 3, whatever you do to the denominator, you do to the numerator. So to rewrite our problem, we have 1 5/12 minus, now using our new denominator of 12 and our new numerator of 9. Well, I can't take 9 from 5, so I need to make this whole number a whole number fraction. using the same denominator that we already have. So our whole number becomes 12/12 plus the 5/12 that we already have minus our 9/12 that Jim sold. So this is still Jim's amount. 12/12 plus 5/12 is 17/12 minus 9/12 gives us 8/12. Alright, so that simply means that Dwight sold, so 8/12 is Dwight. Alright, now if we look back at the question, it says who sold more lemonade? Jim. And let's look at, so in order to compare, we need to compare like fractions. So let's look at Jim's amount of 9/12 and Dwight's amount of 8/12. So Jim equals 9/12. Remember, that was the equivalent fraction. Jim started off with 3/4, but that 3/4 became 9/12. So you have Jim's amount of 9/12, and you have Dwight's amount of 8/12. You can easily look at those two fractions and see who sold more. 9 is bigger than 8, so Jim sold more lemonade. Alright, the next question is how much more? How much more did he sell? Well, you have the 9/12 minus the 8/12 equals 1/12. So let's not use our pronouns, since the reading teachers don't want you to use pronouns in your responses. So instead of saying he sold more or he sold 1/12 more, we'll say Jim sold 1/12. Let's be specific and say gallons more. Alright guys, for our last question, Leonard spent 1/4 of his money on a sandwich. He spent 2 times as much on a gift for his brother as on some comic books. He had 3/8 of his money left. What fraction of his money did he spend on the comic books? So just to give us a visual of what we are looking at, we have some money. Alright, we know that he spent 1/4 of his money on the sandwich. Well, we can go ahead and divide his money up into fourths. 1/4 on the sandwich. Alright, then we know that he spent 2 times as much on a gift for his brother as on some comic books. Well, we'll come back to that. Then it says he has 3/8 of his money left. Well, I can actually make these fourths into eighths by dividing them in half. Alright, so if he has 3/8 of his money left, then this is an eighth, and this is an eighth, and this is an eighth. So I can look at that and say, well, that's 3/8, and that's what he has left. Alright, so let's do some actual subtracting here. We have 1 whole amount, so we're back to our 1 whole, minus the 1/4 for the sandwich, and then minus the 3/8 that he has left. Alright, so 1 whole minus 1/4, looking at my 4 as my denominator. My 1 whole is going to be 4/4 minus 1/4. And if you guys are hearing dings go off, it's my cell phone. I'm sorry, I've got Chad at home and he's still recovering, but he's doing okay. Alright, so 4/4 minus 1/4 is 3/4. So he has 3/4 money left after he bought his sandwich. And then he spends some on a gift, and he spends some on some comic books, and then he has 3/8 left. So we'll go ahead and take away the 3/8 that he has left. All right, now again, we have 4 and we have an 8. Which of these denominators can become the other through multiplying? We can do the 4. 4 times 2 can give us 8. And whatever we do to our denominator, we do to our numerator. So 3 times 2 is 6. So to rewrite our fractions, we have 6/8 minus the 3/8 that he had left. And 6/8 minus 3/8 is 3/8. All right, now the problem says that he spent 2 times as much on a gift for his brother as on some comic books. So if you have 3/8, what you really have is 1/8 plus 1/8 plus 1/8. Well, if he spent 2 times as much on a gift, that's telling you he spent 2 times the amount of the comic book. Well, you only have 3 choices here, and so you know the comic book is going to be one of them. So the comic book is here, and then he spent 2 times that amount on the gift for his brother. So he spent 2/8 on a gift for his brother, and he spent 1/8 of his money on a comic book. Guys, make sure that you have everything written down here on your paper. All right, so it's a lot of information here, but it is very important that you have everything written down and recorded. You are going to spend probably just about 15 or so minutes on working on your homework. Whatever you do not finish, I do need you to finish for homework tonight. I will check it. I will be at school Tuesday, so I will be checking for homework. Make me proud. Make sure you do what you need to do, please. Be the great students that I know you guys are. Thank you for understanding why I am out today. Again, make me proud. All right, guys, I'll see y'all tomorrow. Bye.